This is a sample problem for horizontal circular motion. So when you have horizontal circular motion, your circle is totally flat, and the only force that you really have on it is centripetal, which is like a net force. So gravity is pointing straight down, so it doesn't impact how it's moving. And there is a force of tension, which is keeping the string intact, which is why it's swinging around a circle. And that, in this case, is going to be equal to centripetal for a horizontal circle. So for this problem, what we have is a ball on a string, which is 0.15 kilograms of mass. The radius of the circle that it makes is 0.6 meters. And it is going to make 2 revolutions every second. There's a couple things we have to figure out. Now we want to figure out what the force needed is, and that's going to be the centripetal, but it's also going to be equal to the tension. So we want to find what that is. And because it's horizontal circular motion, we don't have anything except for the centripetal force acting on the problem. So what we have to do first is try and figure out the velocity. So we know that the period is going to be the total time divided by the number of revolutions. So that's going to be 1/2. So the period is going to be half of a second. And that period is going to tell us that it's going to always make 1 rotation in that amount of time. So then from there, what we can do is use that information to figure out how fast it moves, because the formula for centripetal force is mv squared over r. So we need to know the mass, the velocity, and the radius. Now we have the mass, we have the radius. What we don't have is the velocity. Now because we're looking for a linear velocity, we either have to find the angular and then convert it, or we can go right to linear by doing circumference divided by period. Now your circumference is 2 pi times the radius, which is 0.6, and the period we found was 0.5. So 2 pi times 0.6 divided by 0.5 is going to give us 7.54 meters per second. Now that we have the velocity, then that means we can take that information and put it right into the centripetal force equation, which is also our tension, like we said. So that's going to be mv squared divided by radius. Mass is 0.15, and now we have our velocity of 7.54, which is squared, and then divided by our radius, which is again 0.6. So when we go through all that, we're going to end up with somewhere around 14 newtons. So that's the force that it needs when we swing it around in a circle. So what we would really need to do if we let this thing go is see where it ended up flying away to, because of the fact that it has a tangential velocity, but we actually don't even need to worry about that. The problem itself is finished at this point. And that's because a horizontal circle really only has one force, and that force is tension, which is equal to centripetal. And it's going to be the same at all the points, which is different from a vertical circle where it's different. But in terms of problem solving, this is really all that you need to worry about.